So before going much deeper and start writing code in PyTorch, I mean basically building deep neural networks, CNN, RNN, LLM, whatever you wanted to do. Just want to quickly touch base upon this activation thing, right? So if you see, like in our previous videos, we only talked about how neurons and neural network is formed, right? So in this manner, you will be having input layers, you will be having output layers and hidden layers. Okay, these three units that we have mentioned in our previous videos. So one typical problem to learn complex real life situations that we are trying to solve using mathematical model is that real world does not support linear algebra, or in real world things does not happen linearly, right? It might have some errors, noise and all those stuffs. It creates a complex pattern basically for us to learn, right? So to solve the complexity of any problem in mathematical problem, basically neural network implements one nonlinearity function, basically, that is your activation function. So think of activation function as let's say you can think of it like third political party, when there are two different equal strength parties, let's say fighting with each other with, let's say, 40 or 42% vote share, and there is another third party that has 5 or 6% vote share, and based on the vote share of the third party, they will decide who will win the actual election. So think in that manner as your activation. So that third party brings non-linearity, or else it will be a straightforward thing, right? Either this one will win or this one will win based on the vote percentage. You can definitely identify. But once you introduce another party, what it is doing, it creates a puzzle. You don't know like which one will win until the whole counting is over. So that's a non-linearity into your model. I mean, your simple model becomes very complex. So that's what your activation function does. So here you can see, right, if you see this one, right, you have the inputs, you have your weights and biases, and this is nothing but, as we have previously also mentioned, it's summation and multiplication. So it creates a linear stack basically, right? But this linear stack, no matter how complex your hidden layers and this whole architecture will become, this basically linear stack is still solvable using linear algebra, right? So that means it is not able to solve complex problems. To complex, make the equation bit complex, or to introduce some challenge into the network so that it can solve a real world problem where the gradient, basically, where the loss curve will not be let's say a convex loss curve mostly. So in that cases, what we are going to introduce, we are going to introduce another function. In the function, you can represent it as f of something, f of, let's say z1, z2, z3, something like that. Okay, so that f of z1, z2, z3 is nothing but your activation. So always remember just one thing, one liner, your activation is nothing but the non-linearity into the neural network. So what are the different type of activation functions here? So I hope you guys already are aware of all of this. So I'll just go to each one of these very briefly so that we can save time. So first, let's say ReLU, widely used. So what ReLU does, basically how it brings non-linearity. So if your value of neuron or value of input, basically that's coming to the activation, is positive, it will return you that value. That means the gradient or derivative of that value, if you do, you will get 1, and vice versa. If it is 0 or negative, you will get 0. So that's what ReLU is. So why we wanted to use ReLU inside our neural network? First of all, it is very fast and simple for calculation. Then there is no problem regarding vanishing gradient and all, and it is a default choice for your hidden layers in deep neural networks. So just remember this one. That's why ReLU is very important. Okay, but it has a problem that's called, that is its dead ReLU problem. That means this 0 1, right? So this one it has a problem. So when the input value, let's say, is negative or 0, it will make the output as also 0, right? So that will create a dead ReLU problem. To solve the dead ReLU problem, they have introduced Reiki ReLU, where what happens, if you have the negative values, you just multiply the value with a very small gradient, let's say 0.01 or 0.001, and this particular constant term is nothing but your alpha value. So that's how you create leaky ReLU, and you can use leaky ReLU in many of your problems to solve the dead ReLU problem. Now the next one is your sigmoid. So sigmoid, when you will use mostly in binary classification, where you will be requiring output from 0 to 1, in that case you will use sigmoid. It has a gradient vanishing gradient problem. Likewise in 10H also you will have the vanishing gradient problem. So to solve these things, you use ReLU or leaky ReLU kind of activation, but mostly in binary classification with cross entropy loss we use sigmoid. And 10H in some cases, 10H mostly I think we use in LSTM, GRU, all those stuffs, in all those gates. So one another thing I just wanted to touch base here is GELU, this one. So it's a Gaussian error linear unit. So this activation is widely used in your transformers and LLMs. So why it is used in LLMs and transformers? Because it has a very smooth activation and it has a better performance in very deeper neural models. So you know the LLMs or transformer architecture has a very stacks of sandwich layers. So in that case, GELU, this activation, Gaussian error linear unit, it works perfectly. So okay, that's it for this video. Just wanted to touch base upon the activations of your neural network. In the next video we'll try to do hands-on with activation in PyTorch. Thank you.